So today we're going to be talking about angle relationships within polygons. So this chart here, we'll talk about polygon, regular polygon definitions a little bit later on, but we also talked about it last lesson. So within this chart, we're going to be talking about the number of sides that a polygon has and how we determine the angle relationships within that polygon. So for a three-sided polygon, which we know to be triangle, the diagram looks like this. How many triangles can we create from a three-sided figure? Well, we create one triangle. We know that the interior angles of a triangle all add up to 180. We see one triangle times 180 degrees. It gives us 180 degrees. If we were looking for each interior angle, well, we would take the sum of the interior angles, which is 180, divide by the number of sides, which would be 3, and it would give us 60 degrees. So this angle, and that angle are all 60 degrees on a regular polygon. If we're looking for the exterior angle, well, the exterior angle, if I go back to the diagram and just draw this line, we found this to be 60. We're actually looking for this angle here. So we know that that is a supplementary kind of relationship. So it would be 180 minus 60 would give us the remaining angle value, which in this case is 120. The sum of the exterior angles, well, we know it's 120 degrees. How many of them are there? There are 3, because there are 3 sides. 3 times 120 is 360. We move on to a square, 4 sides. How many triangles can we create? We can create 2, 1 and 2. The sum of the interior angles, well, I see 2 triangles. If each triangle is 180 degrees, the sum of this polygon is 360. So 2 times 180 is 360. Again, finding the individual interior angle, sum of the interior angles, which is 60, divided by the number of sides gives us 90. I'm looking for the exterior angles. Well, 180 minus 90 is 90. And then how many of those do we have? We have 4 of those, each at 90 degrees, which gives us 360. So we're noticing a bit of a pattern here in the sum of the exterior angles. I'm going to skip to a hexagon. We have 6 sides, which give us 4 triangles, as we can see in our diagram here. We have 4 triangles, each triangle 180 degrees on the interior, 4 times 180, 720. Each of those individual angles, sum of the interior angles, divided by the number of sides, so we can see that pattern, is 120. We're looking for the exterior angle, so if I draw on that diagram again, so we found the interior angle, we're looking for the exterior angle, 180 minus 20 is 60, and how many of those do we have? Well, we have 6 of them because there's 6 sides. 6 times 60 is 360. Last diagram, we're going to talk about heptagon. 7 sides, we get 5 triangles. 5 times 180, the internal angles, or the interior angles, all add up to 900 degrees. Each of those angles is 128.6. Each exterior angle is 51.4 degrees, and the sum of the exterior angles is 360 degrees. So if we notice a bit of a pattern here, if we talk about the relationship that we see, is that depending on the number of sides dictates the number of triangles we have. The pattern we see is that the number of sides minus 2 gives us the number of triangles. 7, 5, 6, 4, 4, 2, 5, and 3. So in order to determine the number of triangles within a regular polygon, n minus 2, number of sides minus 2. How do we calculate the individual interior angle? Well, n minus 2 times 180. However many triangles we create times 180. Pardon me, that would be the sum of the interior angles. How do we find the individual angle? Well, the sum of the interior angles divided by the number of sides, right? And we saw that up here. The sum of the interior angles divided by the number of sides gives us the interior angle value. And then we have 360 degrees to be the sum of the exterior angles. So in summary, the sum of the exterior angles of any polygon is 360 degrees. For a polygon with n sides, the sum of the interior angles in degrees can be found by 180 multiplied by n minus 2. A regular polygon is a polygon where all the sides and angles are equal. So I'm just going to dive right into some examples here. I'm not going to do every single one of them, just enough to kind of get the point across. So the first example we have, determine the sum of the interior angles in a polygon with 15 sides. Okay, so 15 sides, I know that is going to be my n is equal to 15. Sum of my interior angle, well, we know that to be 180 minus, n minus 2, multiplied by n minus 2. So I end up getting S is equal to 180, 15 minus 2. Sum of the interior angles, 2,340 degrees. So on the inside of a polygon with 15 sides, the interior angles all add up to 2,340 degrees. Second example we're going to go through, example 3. Determine the number of sides in a polygon if the sum of the interior angles is 540. Okay, so a little bit different now. We're not given the number of sides, we're actually given the sum of the interior angles as a value. So if we're going to use the equation of S equals 180 bracket n minus 2 to find the sum of the interior angles, and we are given the sum of the interior angles, that would be our S value. So 5,400 is equal to 180 n minus 2, right? We're trying to determine the number of sides. So we're essentially trying to isolate for n. Well, in this n minus 2 bracket, it's being multiplied by 180. So I can go ahead and divide that by 180 to eliminate, to start to isolate for that variable. Then I take 5,400 divided by 180. Then I'm left with my one side of n minus 2, and my other side of 30. And then my n value would be 32, right? So number of sides, therefore number of sides is 32. All right, third example, example 5. A Canadian $1 coin is a regular polygon with 11 sides called a undecagon. Determine the sum of the interior angles of the loonie. What is the measure of the interior angles? Okay, so I have my interior angle formula. So I'm looking for the interior angle. If we remember how to do that, that would be 180 multiplied by n minus 2, right? That would be the number of triangles that we have, all over or divided by the number of sides that we have. Well, in this case, 180, where is our n? We have 11 sides, so it'll be 180, 11 minus 2, all over my number of sides, which is 11. So then I'm going to have 180 times that would be 1620. Look at the wrong example. 1620 over 11, which would give me 147 degrees, or 147.27, but I just rounded that to 147. Example 7. If the interior angles of a regular polygon are all equal to 160, find the number of sides the polygon has. Solve algebraically. So interior angles are all 160. So I'm just going to state that kind of formula or that expression again, where the interior angles is equal to 180 n minus 2 all over the number of sides. But this time I have my interior angle value of 160. So I'm simply going to plug that in for my interior angle, 180 n minus 2 over n. Now I need to go ahead and solve for n, right? So I would bring n up to both sides. So I have 160 n would be equal to 180 bracket n minus 2. Or I can go 160 n is equal to 180 n minus 360, right? I distributed 180 into the bracket. I then have 360, I bring that over, positive 360, I bring the 160n over, which would give me 20n, and then divide both sides by 20. My n value is 18. So the number of sides that this polygon has is 18. Example 9. What are the measures of one exterior angle of a 15-sided regular polygon? Well, if we look at what we have, interior angles, that's what I can figure out. Interior angle, 180 bracket n minus 2 all over n. In this case would be, well, I know I have 15 sides. N equals 15. So I need to find the degree of the interior angle before I find the exterior angle. So in this case, it would be 180, 13 over 15, which would then give me a value of 156. Right, so that is the interior angle, the individual interior angle. If I want to find the exterior angle, change this up a bit. Exterior angle, I then going to take 180 because I know it's a supplementary angle. 180 minus 156 is going to give me a value of 24 degrees. Right, so this means that one exterior angle is 24 degrees. And I'm not going to go ahead and draw these shapes. But basically what we're really trying to take away from this lesson, I'm just going to scroll back to the top to that chart, is right here. This is the proof of why we use n minus 2, n minus 2 times 180, and then n minus 2 times 180 divided by n. You can then, if we zoom out, we can see that we can determine the sum of the interior angles by using this. And these are the examples that we use to prove that. We know that we can determine the individual interior angle by taking n minus 2, multiplying it by 180, and then dividing by the number of sides. Again, we use these four examples to prove that as well, okay? So hopefully that kind of shed some light on the relationships, the angle relationships in polygons, but knowing which formula to use is going to really help you when trying to solve those problems moving forward.